3x squared. It gives a nice function, 3x squared, right there. 3x squared, 3x squared. And it's asking for two things. What's the first row it's asking for? What's the first row that it's asking for? Evaluate. So that really is the, what do you do to evaluate a function? You just
enter the number that you're given.
Yeah, so do this for me. Enter all those numbers in right there and fill in the first row of that table. Enter in the first row of that table, please. So what's the second row asking for? What's the second row asking for? Not the function evaluation. What's it asking for? F prime, the derivative of the function at that value, the derivative of the function at each of those values. Now, why is this a little bit more work?
It takes a super long time to do it for each value.
Yeah, so let's do this here. We have 1, 2, 3, 4, 5, 6, 7 values. Okay, you're going to be -2, Chris. Arvin, you're going to be -1, 0, 1. Andrew, you're 2, 3. In the back row, you both do 4, okay? So you're going to divide and conquer here. Does everybody know what number they're supposed to do? So what's the first thing you write down when you're calculating this?
F of a plus h minus
Limit as the limit, make sure you put that in there, limit as h goes to 0 of f of a plus h minus f of a all over h. So then also in the back row, Noah, I'd like you to do 4, David 3. You're going to do 2 of these. Those numbers are correct. Those numbers are correct. So that's a decent amount of work, right? The divide and conquer as we fill in this chart. So finding derivatives is challenging. So let's take a look at this for a second, though. Let's take a look at this. One thing you've done many times in Algebra 1 and Algebra 2 is you've been given a chart of values. You've been given a chart of values, and you found the what based on the chart or the table. What have you found based on the table? You found the... So if I gave you a table of values that look like this, I don't know, like x and y. You've done things like this before. 1, 2, 3, 4. Let's do 8, 16, 12, 11, 4, 8. Let's do this. 8, 12, 16. I'm trying to come up with one off the top of my head, and I'm apparently failing here, but let me just do this. 1, you've been given things like that, and what's one thing you've had to do if I just presented that to you? What's one question I could ask you based on that table? Find the equation, right? So guess what I'm going to ask you right now? Same thing, find the equation, but instead of so these are our x values we're going to use right here. I'm going to relate x to what? It's going to be x as your x value, and what's the y value? What's the output going to be? The what? F prime of x. So what I want you to do is figure out what's the function that links x to f prime of x. Basically, how do you turn x into x prime? So how do you turn, what rule can you find, if there is one, that turns -2 into this, like this, into this, does the same thing? What is the rule? Can anybody see what the rule is that turns, it's the same thing each time? Anybody see it? What is it, Andrew? What?
Multiply by 6.
Multiply what by 6?
X.
Yes. So f prime, we're saying f prime of x is equal to 6x. We think that's true. We think that's true. We think that's true based on 7 values. Now, how many numbers are in the domain of 3x squared? How many different numbers are in the domain of 3x squared? An infinite number. Can we test every single one of them? No, you can't test every single one of them, right? You can have 6 values, and we think that this is the function. If this is the derivative function, why is this really helpful? Well, what happens if I asked you, what's the derivative at x equals 5? What's the derivative at x equals 5? What's f prime of 5?
30.
Yeah, because that's just going to be 6 times 5 is 30. Did we just bypass all that work you did with the limit? Yeah. If that is indeed the derivative function, we can now just plug in x values into a function and get values really quickly. Is that helpful? It is very, very helpful. How can we do that, though? How can we do that? Well, we can't test every value, but we could do the general case. We could do the general case. So instead of plugging in, you plugged in the number 4 and the number 2 and the number 0 and the number 1. Instead of plugging in a specific number, we could plug in the number a. So what was that limit again? The limit as h goes to 0 of what? F of a plus h minus f of a over h. And our function, f of a, is going to be 3a squared. Do you agree with that? That's our function. Because what was f of x? F of x was what? 3x squared. So what is f of a plus h? Where do you plug in the a plus h? You plug it in for the x. You take a plus h, and where do you plug it in? The x value. So let's plug that in, and what do we end up with? 3 times what? A plus h squared. So what do we do now? We take these values, we take 3a and we plug it in there, and we take this one and we plug it in there. Let's see what happens. The limit as h goes to 0 of, what is it? 3 times a plus h squared minus all over h. Now we want to cancel that h out, so what are we going to have to multiply out in the numerator? A plus h. So you have the limit as h goes to 0 of 3 times a squared plus 2ah plus h squared minus 3a squared over h. Anything cancel there? Well, you get 3a squared plus 6ah plus 3h squared minus what? 3a squared over h. What cancels on top? The 3a squareds are gone, right? Do you agree with that? Yeah. So what do you end up with? You end up with the limit as h goes to 0 of 6ah plus 3h squared over what? H. What can I factor out of the top? H. So you get the limit as h goes to 0 of h times 6a plus 3h all over what? H. What cancels? H. The h's cancel, leaving you with the limit as h goes to 0 of 6a plus 3h. If h goes to 0, what does that go to? 6a. So we just proved that for any number, what's the derivative? 6a. We did the general case and we proved that the derivative is 6a. So is that really helpful? Absolutely, because I could give you any x value and can you quickly find the derivative? Yeah. What's the derivative when x is 4/7? 6 times that. So 24/7. You just multiply by 6. So let's go down here for a second. This is asking a very similar question where it's asking what's the function? What's the function? What's the general form of this? Again, write it down. Limit as what? H approaches 0 of f of a plus h minus f of a all over what? H. Find the board. Go to the board with somebody you're not sitting next to right now. You're not sitting next to that you've not worked with. And, okay, so I think you guys got this. F prime of x ends up being 4x plus 3. Think it ends up being 4x plus 3? Everybody? Yeah, I don't know what's going on. Okay, kids, algebra, it's important. So that last statement right there, it's going to be just equals on that last one, not limit as h goes to 0. So it cancels, and then it equals 4x plus 3, 4a plus 3. So in this case, what is the derivative of this function? 4x plus 3. You can clean up your algebra later, but the idea is the h should eventually cancel. And especially when you're dealing with a polynomial, you will get a clean answer when you're dealing with a polynomial. You will get a clean answer when you're dealing with a polynomial. Learn here. So what did we have here? Let's just take a look at this. We had f of x is equal to, what was it, 3x squared. And what was the derivative? Do you remember the first derivative? It was 6x, right? We now had f of x, we had a different one, which was 2x squared plus 3x minus 5. And what was the derivative? Well, it was 4x plus 3. So let's just keep those in a little box right here. So far we've found two derivative functions. We found 2 derivative functions. Let me just pause and see. Does anybody see a pattern yet? Anybody see a pattern? Anybody see a pattern? So you still have to do a bunch of work, right? Anybody see a pattern? What do you see, Chris? What do you think?
Exponents and a leading.
Yeah, look at that. So 3x squared. How do you turn 3 into 6?
3 times 2.
3 times 2. Is there a 2 already there? What do you see? What's 3 times 2? 6, right? And then what does that exponent become? What does this exponent become? A 1, right? Oh, what do you see over here? What's this? What do you see? 4. You see 4 right there? Yeah. And what does the exponent become? 1. Oh, what does what's this number right there?
3.
That 3 is right there. What invisible thing is next to the 3 right here? X to the 0. X to the 0. X to 0. So there's a 1 there and it turns into a 0. So is there a pattern here? Yeah. Is there a pattern? Yeah. So for example, and what's that? Oh, that's a constant. What's the rate of change of a constant? What's the rate of change of a constant? What does constant mean? Not changing. So what's the rate of change of a constant? 0. Oh, it is there. It just became 0, right? So I have a question for you. Let's say I said, I don't know, g of x was equal to 3x to the 4th minus 2x squared plus 8x minus 5. Anybody want to take the big guess as to what the derivative is? Anybody want to take the big guess as to what the derivative is? Fitch, what is it?
12x plus
12x to the
first
careful
squared
Why is it not squared?
Third.
Cubed.
You just take one off?
You just take one. Oh, maybe. This is what we're guessing. What do you think the next term is? What's the next term? Minus what?
4x.
4x. Yep. Plus what?
8.
Done. That is the derivative. Oh, sweet.
How
Boom.
do we get 12x cubed?
Because you take the power and you bring it down 1. 4 turns into. So look, the 4 turns into a 3, and the 2 turns into a 1, and then the 1 turns into a 0, which you don't write in there. Is that pretty cool? Nice. So you're going to be doing a lot of that. A lot of that. But let's do this one first. A person walks away. What? We're going to talk a little bit more about why that's true, which we've kind of done already a little bit. Remember that general thing we did over here? Yeah. We did this one, right? You can do it in a similar fashion. You do it in a similar fashion. Okay, so let's talk about this one. A person walks away from home on a north-south path. His distance from home is given by the formula f of t is negative t squared plus 6t, where t is seconds and f of t is in feet. Evaluate and interpret the following. What does f of 1 mean? So f means his distance from what? From what? Distance from home. So what does f of 1 mean in sentence form? What does this mean in sentence form?
1 second from home.
1 second from home is the number 1. So what does f of 1 mean?
How many feet from home?
He is at.
A second.
So what's the full sentence? F of 1 means what? F of 1 is?
How many feet
the distance, yep.
from home
He is from home
after
after 1
1 second.
second. That is the distance the person is from home after 1 second. Does that make sense? What does f prime of t mean? F prime of, let's make it different. F prime of 1. Let's do that first. What does f prime of 1 mean? Prime means what? We talked about this repeatedly and you were asked about it. What does prime mean? Prime is the same thing as derivative, which is the same thing as
Is it
instantaneous rate of change. So what does f prime of 1
the
mean?
amount he gets away from home after?
At that instant,
How fast is he walking?
walking what?
Away.
Away from home. How fast
At 1 second.
How fast is he walking away from home? Away from, I can almost write an H. From home after 1 second.
Wouldn't it be he is, not is he? So
How fast, yeah, he is. How fast he is, thank you. How fast he is walking away from home after 1 second. After 1 second. So what's the only word that changes if I say f prime of t? So if I do f prime of t, what's the only thing that changes? What's the one word after what?
unit time.
After, literally change one thing about that sentence. One thing. What's the one word?
How fast?
No. 1 is a unit of, where in the sentence is that? It's right there. So what's the only thing you change?
T seconds.
T seconds. So what's this going to be? How fast he is walking away from home after what?
After
After
T seconds.
t seconds, exactly.
Oh, I thought you
T seconds. Yeah, I'm sorry. I wasn't as clear as I could have been.
I thought you were talking about the first sentence.
Oh, after t seconds. Sorry. I'm sorry, not the first one. Yes, purple, 2, 1. Yes, on this B, part B, I meant part B, yes. So all f prime means is that. So can you tell me, based on the big hint I gave you, what is f prime of t? What's the function? Anybody want to raise their hand and just tell me what f prime of t is? Can someone tell me? Raise your hand. Don't say it out loud. Can someone raise their hand and tell me what is f prime of t? Prime of t.
T plus 6.
Careful, not. Careful. Keep going. Yep.
Negative 2t.
-2t plus 6. -2t plus 6. Because what do you do with the exponent?
Multiply.
You bring it to the front. What's the leading coefficient of the original function? -1. So it becomes -2. And what does the exponent? Oh, you drop the exponent down 1. And oh, look at that. This is pretty cool. How fast he's moving away from him, you can think of that as velocity in one dimension. He's going back and forth. That's it. It's not going very, it's not. Okay. Just tell me, what's f prime of 1? Look at the board. 4. What's f prime of 5?
Negative 4.
-4. Do you agree with that? Raise your hand if you agree with those numbers. So if f prime of 1 is 4, what does that tell you about how fast, what does that tell you about his motion? Is that a positive or a negative number? It's a positive. 4 is a positive number. 4 is a positive number, right? So what does that tell you he's doing? Well, he's walking fast, but that's relative, but it's positive. What does the positive aspect tell you?
He's walking north.
He's walking north. This means he's walking north. And this means he's walking...
Switches direction.
Yeah, it's yes, that's the whole point. Like, you're going to do that all... He's walking what?
South.
South. Here's an interesting question for you. How does the speed at those times compare? How does the speed at those times compare?
It's the same.
Yes, because speed doesn't have what? Direction. It's this would be not speed, this would be more what? Velocity, exactly. This is one-dimensional because it's either going north or south. He's going up and then down and up and then down. Great, exciting, so exciting. Okay, so this is the worksheet we're going to work on right now. Finding the derivative right here. Finding the derivative function. Finding the derivative function. So let's take a look at the first one here. Let's take a look at the first one. So if I ask you for the derivative, you know what the derivative is of the first one. Can you tell me what the derivative is of the first one? What's the derivative of the first one? Just look at it. Don't do any work. Just look at the board. I don't want you to do any complex thought. Just what is it, Noah?
Negative 4x.
Negative 4x. But how do you prove that it's negative 4x? What do you have to do to prove?
Case.
You have the what? The general case. So what do you actually use? You use the limit as h goes to 0 of, you're going to write this out, minus f of a over what? H. But what is f of x in this case? Negative 2x squared. Do that for me. Prove that the derivative is negative 4x using the general case. Use this, use the limit definition of derivative to prove that. Common organizational mistakes that people make. Hold on, what are some common organizational mistakes? They don't write the limit in every single time. What else do they do?
Forget to write the h in.
They don't write the h in, and then you also put the fractions so close together that you can't tell what's a fraction and what's just a over b over c over d over e over e over f, and it's really hard to follow. So make sure you see the space in between the lines, everybody? Like you see there's space. You see that? Is that really helpful? Yes, it's super helpful. Super. If you wanted to do this one quickly, what's the quick method? What would you have to do first before you could do the quick method? What would you do first?
Factor of the
Not factor, it is factored, so you'd have to multiply it out. So if you multiplied that out, so if we use the quick method that I hinted at, that we haven't proven yet, if we multiplied this out, if we actually multiplied, let me use a red here, that would be negative 2 times x minus 3 times x minus 3, right? What is that? Negative 2 times what? X squared minus what?
6x.
6x plus 9. And that's equal to negative 2x squared plus what? 12. Oh, 6x. There's an x right there. Sorry. Plus 12x, right? Minus 18, right? So if that's f of x right there, based on the rule we think is true, what's the derivative going to be? It's going to be negative 2. You drop the 2 down, x to the first plus what? Is this what you guys got?
Yeah.
It is what you got. So this is the quick way of doing it, but to prove it's true, you have to use this. And if you can't do this, you're not going to be allowed to use this.
So has there been things that have shown that this isn't perfect?